Okay. I just want to just go to the question. After that, the team wants us, the team has a few other ideas and maybe a few questions that we can tackle to understand what an inverse of a matrix is through first principles. Um, if anyone from the team can speak up.
Yes, sir, we are here.
Yeah. Can you, do you want to take over now or do you want to go ahead with the first question?
Yes, sir, we can take over. Yes, sir, we can take over.
Yeah, thanks. Thanks.
So you can stop the screen sharing from your end,
Sure.
or whosoever is sharing the screen. Yeah, let me share the screen right now. Yeah, I hope that the screen is visible to everyone. So today we are, it's rather a revision session, so that I might, we might get to know that our audience is feeling very energetic about the sessions and they are truly learning. So while skimming through the questions, let me give a basic, key takeaway points or key points that you can definitely take them away with your home. So my name is Akshay. So every day you are seeing new faces, and that is how variable our team is. We have all sorts of people. Like yesterday I was at the back end. Today I'm taking the session for 10 minutes, then I will call another teammate of mine. So let me skim through the questions. So if we go through the module 1, it is totally updated, so it is totally a dynamic session. It would be for you. Like, let me revise the previous questions that we had already covered. Like, question number 3 is plot the lines y is equal to x, y is equal to 2x, and y is equal to 10x. So in the first session that we had actually plotted these lines over GeoGebra, and let me give you a basic hint of what actually the question wants to say. Y is equal to mx plus c. So by basic algebra, we know what these equations actually are and how we plot them. So if you see, or if we see our plane, or the four quadrants, first, second, third, and fourth. By basic 10th knowledge, we know that this is the basic equation of line. And how do we plot this? We just first calculate the value of c by putting x is equal to 0. We get some value over y-axis. Let's suppose that c is coming out to be positive, and it is cutting the y-axis over here. And then the x-axis over here, we plot the line. And similarly, if c is 0, so when x is 0, y automatically turns out to be 0. And thereby we can see that y is equal to mx would pass through origin. There's a key takeaway point, that if c is 0, then the line would pass to origin, which we had actually seen by varying values of m and plotted using GeoGebra. Now, next up we have uh, fourth question is also repeated. Fifth question, I hope that you are getting to know that y is equal to 2x plus 1. It's a line that does not pass through origin, because if you put 0 comma 0, that is satisfying the equation won't be satisfied. Thereby 0 comma 0 is not, that is the origin, is not the solution of this equation. So a very basic concept. I hope no one is having any sort of doubt. If you have any sort of doubt, please get it clarified. Any redundant error that you might find in your memory, rather, using computer science terms, you can definitely ask me. Any doubt in plotting, in basic maths. This is rather repetition of what we had done, recursion, right? So yeah, question number 7, we can see that where we introduce matrix to the picture, we are getting this matrix picture now. That how can we represent two equations using matrix? It just putting the coefficients into the matrix. Suppose we have two equation, ax plus by equal to c, or rather a1 b1 c1, a2x plus b2y is equal to c2. So these are the two equations. We can put it into the matrix format, right? Put these as column same, put it same as it is, a1 a2 b1 b2. And basic matrix multiplication, we are just taking away, we are going with the flow. But as soon as the lecture proceeds, or the series proceeds, we would introduce much higher series that actually introduce you to what is vector, what is matrix, and how these are actually intricacies of the same word. These are the two faces of the coin. A coin is not different. The faces are actually the same and all are interlinked connections. So another thing that I wanted to say right now that reminds me that you can comment anything and any sort of doubt. We have our team solving it, and rather to make the session interactive, they would be posting some questions you can answer in the comment section. Matrix, again a matrix from the past two lecture. Matrix is just a function. Matrix is basically a function which matches x comma y to a new value, c1 comma c2. Basically, when we find x comma y, what are we doing? We are finding actually the value of x and y that matches that the pre-image of c1 and c2. Thereby matrix is a function. Soon we would be talking about function very soon, very soon. On to, and see, if you go through the questions today that have been posted in the module 1, you would very easily see that the thing that we had doubts in yesterday, one function, on to function, have been very clearly removed from those. Thereby new sort of questions have been posted in, so that we have less and less doubts and more clarity. We are making our vision more clear. Okay, so matrix multiplication. Matrix is basically a function which matches the coordinate x comma y to c1 comma c2. Let me give you a bigger insight. There can be also matrices which can match x comma y to c1 c2 c3. Two variables to three values. We would dive into that ocean very soon. A1 and A1, A2 and B1, B2, we have put the values over here and we can solve it. Yesterday, my friend told about inverse of the matrix, which is not at all really required right now, but talking about it very soon. A1, A2, B1, B2, inverse into C1, C2. Any sort of doubt over here? I have just used the inverse symbol over here so that I am not calculating it. Let me tell you one short trick that we have been using since years for a 2 cross 2 matrix. Like if we have a 2 cross 2 matrix right here, A1, A2, or let me put it directly through a question, A2, B1, B2. What is the inverse of this matrix? We know that just a clear definition, A into A inverse is I, identity matrix. We can calculate it very straightforwardly. Like what you are going to do is interchange these two, so that the inverse would look like this, something like this: B2, A1. Put a negative sign over these entries, minus B1, A2, minus A2, and just divide it with the determinant, whatever the determinant of A is. So let me go. Let me take an example to elucidate it very further. 4, 5 random entries minus 1. What you're going to do is just invert these. What we did is minus 1, 4. Invert the diagonal entries for a 2 cross 2 matrix. This method is valid only for a 2 cross 2 matrix, just for the easy thing and just for the fast calculation. Invert these two entries and put a negative sign over these two, minus 5 and 0. What about the determinant? The determinant over A is minus 1 by 4. Bingo, we have the inverse. This is the inverse of the matrix. Thereby, multiply with this with the column C1, C2. And you have the values of x and y, the pre-image of C1 and C2. So yeah, this is a very simple thing. If you have any doubt, you can speak right away or you can post in comments. Any doubt? Any sort of doubt? We never say no
Why
to
does this
doubt.
method work?
Sorry?
Why does this method work?
Actually, this is basic observation. Like if we go into the details of inverse, there's something known as adjoint, and there are other definitions to it. This is just a basic observation that we had basically calculated and directly we are using since our 10th and 11th definitions. Although if you want to find the prerequisite way, the way we do it, you would end up landing over here only. It's just for 2 cross 2 matrix it works and makes your calculation a bit faster. That's it. There's nothing else. So even if you don't want to use it, you can go through the defined way. But if you want to be a bit faster, you can use it essentially. There's no harm. Next up, if you are sorted out, so next let's go to question number. Question actually we are actually going through the questions for the first time right now. Thereby we are trying to find the questions which are repeated. So question number 13 is repeated question. 13th. We know that phi of x comma y, again a function thing. I know it would be new for a few people over here, but still I would say just take it away from me. We are going to dive into this concept very soon. No worries, and if you have any sort of doubt, keep posting on comments. We would definitely answer to those questions. Phi of xy changes x to uh, over here is 2x plus 3y, comma, and 3x plus 4y. So what basically is done to x is x changes to 2x plus 3y. Y changes to 3x plus 4y. There is also graphical approach linked to this concept where actually inverse was originated from, but we are saving the best for the last. We would definitely take that concept, but for the time being, we say that 2x plus 3y. Basic observation: how can we achieve 2x plus 3y from x? If we see the matrix multiplication very carefully, a1, a2, b1, b2, multiplied with x comma y. This is a function which changes the coordinate x, y, other coordinate, some other parallel universe working over here. What actually we obtain is a1x plus a2y, b1x plus b2y. Just match these. A1, we can simply see that a1 is 2, a2 is 3, b1 is 3, b2 is 4. Bingo, tada, we have the answer. Thereby, a1 was 2, a2 is 3, b1 is 3, b2 is 4. Here is the answer. So by basic approach, very basic approach, just by multiplication's sake, we are able to solve this question, and we are genius. So, diving into a bit concept further, this matrix takes these coordinates to these coordinates, mapping them. And if you know a very basic thing about functions, what are they? They're mappings. They are mappings, changing one coordinate to another. This is what it is doing right now. So, any doubt? Any doubt? Proceeding further, uh, do we have any redundant question?
Sorry, can I ask a doubt?
Yes, sir. Yes, sir. Please
Yeah.
go on.
Yeah. So, what did you mean by mapping a coordinate to a coordinate?
See, I can give right now a basic gist about it, because functions is yet another topic to dive in. So if we go through that, there is a function f that we define. Y is f of x. So x is being mapped to y. X is being mapped to y. Thereby, there is a set. There is a bucket. There's another bucket. One person takes x from it. Another, say there are two buckets, A and B. There is an element, there is a ball, suppose, in a bucket A. One person takes X from bucket A, another person takes Y from bucket B. They have their own definition in their own words, A and B, but they're actually the same. They are actually linked in some sort of mathematical operation. This is basically a function. There are several conditions that are linked to functions, but uh, as they say, it's never never go larger than life. So we are not going into the exact appropriate concept. This is a basic underline to the star, underline to the function concept. X is mapped to y, thereby if we take x from A and y from B, they're same. There's no difference. Since this functions that we generally deal, so sorry, if you have any doubt.
Yeah, so you're mapping x to y. I understand that the mapping, but what do you mean by mapping coordinates?
Mapping coordinates, if we see, this is a one-dimensional thing. Since till 10th, 11th, 12th, what we do is we map one direction of element, one dimension of element to another dimension of element. But basically over here, if you see, we link xy to AB. There is a second dimension thing. And but who can do it better than a matrix? Thereby matrix is a function. Thereby matrix is a function. So the basic, very basic definition or very basic outline of the actual curvature. The thing is, where matrix matches two dimension to two dimension, but it doesn't link. It doesn't define its boundaries till two dimension. It can also proceed further, but for the most basic example is x comma y to a comma b. As we see, x changes to this, y changes to this. By how? Some multiplication, some addition. That's it. There's nothing else. Hope I have
Yeah.
answered. So,
Yeah, understood.
any redundant question? I feel that all the questions that had been actually covered in the previous lectures have been covered, have been actually taken a basic gist or basic definition. Any doubt, any sort of doubt, if you have in previous lecture, ask right now. Else we can proceed further to do a bit questions for forward, because we are not having a lengthy lecture today. We just we wanted to maintain the hat trick. It's the third day of continuous lectures, so yeah, let's not keep it very heavy, so that you have the time to properly digest the concepts and go through, skim through questions further, and you can try them on their own, because they're going to be anyway covered in the classes with GeoGebra as the C that is swaying our boat. Any doubt? If you have any doubt, you can definitely speak in or raise your hand. So no doubt. Can I invite someone else to continue the lecture forward, so that we can learn, we can dig into a few concepts. The only new thing that I taught was a bit of this mapping and the inverse thing. If you want an example, let me give you one more example. Like, we have a matrix 2, 3, 0, 1, any matrix, random matrix. That numbers jumped right out of my mind. We need to find its inverse. Inverse is basically used to calculate pre-images and images x and y you need to find. What you do is change these two positions, 1 2, put a negative sign before these entries, the circled ones, minus 3 and 0, but we divide it with the determinant. What is the determinant? By basic knowledge, 1 by 2. This is the inverse. You can check as well. 2 0 3 1, 1 by 2 minus 3 by 2, 0 and 1. 1 0 0 and 1. This is the inverse. Identity matrix came right before us. So basic definition. So uh, let me call my mates who can actually carry the lecture forward. Order.
So hello guys. Am I audible? Hello.
Yeah, you are audible.
Yeah.
Yeah, sure. So, uh, like we don't really have like anything prepared right now. So let us discuss some interesting concepts. Like right now, my friend talked about finding an inverse of a matrix. So, let us like understand from the first principles, how do we get to that inverse of a matrix, what it really means. So let me share my screen. Yeah, hello. Yeah. So is my screen visible? Yeah. So I am like assuming that you are like little bit confident with uh, a little bit of vectors. So like you should know what is a unit vector basically. So unit vectors are like not a big deal. So suppose we have an xy coordinate here. we consider a unit vector that points in one particular direction. So uh, uh, like in this case, we call x the unit vector perpendicular to x coordinate as I cap, and the unit vector perpendicular to j coordinate as j cap, right? uh, we also discussed in previous lectures that we can represent vectors in multiple forms, right? So vectors, we have learned in high school physics probably that vectors are quantities which you can represent with a direction and a magnitude. So basically, a vector A will have a particular direction and it will have a particular magnitude, right? But in maths, we can also represent these vectors by a matrix, a column matrix of a numbers. For example, in like two-dimensional space, we can represent this as a maybe a column vector of a comma b something. What this means graphically is that there is a vector which starts from the origin right here and it goes to point a comma b, right? Like if you have any issues you can like just type in the chat or speak on your microphone. There's no issues. And like let's have an interactive session if you don't mind. Yeah. So now that we have established that we can represent these vectors as like column matrices like here a comma b, right? So let us like observe, just observe what magic a matrix can do to a vector, right? So I'll take some random 2 cross 2 matrix. A is equal to 1 2 3 4, right? I'll consider a vector I cap. I cap is like the most simplest vector we can consider. uh, it is just a vector from 0 to 1 in x axis, right? um, so I can represent that vector I cap as I cap is equal to 1 0, because its x coordinate is 0 and y coordinate is x coordinate is 1 and y coordinate is 0 basically. So now like we can just forget for a minute that this 1 0 is a vector. We consider it as just x comma y. Now like I'll multiply matrix A with this whatever we have x comma y, right? So now A is a 2 cross 2 matrix and this is a 2 cross 1 matrix that ensures that this matrix multiplication is actually possible, right? So I'll now multiply this.
So I can look at this as a function, the matrix as a function,
Yeah.
and taking the inputs x and y, right?
Yeah, so I can look at this as a function, right? Similar thing we looked at in previous question. I think it was eighth or ninth question maybe, where we established that a matrix is actually a function, right? So I can consider this matrix 1 2 3 4 as a function phi, which takes a pair of coordinates x comma y and correspond this point x comma y with a point 2x sorry um
X plus 2y and
x
3x
plus,
plus 4y.
yeah, and it corresponds it to a point x plus 2y and 3x plus 4y in some other plane, not the same plane as this. Which means in one plane, let's call it red plane, our point, initial point P, x comma y, corresponds to a point 3x comma 2y. I'm sorry, I'm really sorry. This corresponds to a point x plus 2y and 3x plus 4y in blue plane, right? So from here we can see that this like what input and output we are getting from this function phi. We input x comma y and we get output as this point x plus 2y comma 3x plus 4y. So now we'll like just go back into representing this as a vector form. So when I multiply a vector with I cap, that is 1 0, I get
A is a matrix or a vector?
A is a matrix. A is the same matrix we had here.
Okay.
1 2
1,
3
2,
4 1 0. Now like I'll just multiply this and see what this matrix is actually doing to 1 comma 0, 1 0. That is I cap basically. So that goes to 3. I hope I'm right. Yeah. So this matrix A, hold on. This matrix A takes input this matrix takes input I cap and gives us an output 3 comma 1 1 comma 3, that is this vector. And if, let us also try and plug in some other value, that is j cap, one of the most simple values.
Will come out as 2, 4, right?
Yeah,
2,4.
this will come out as 2 comma 4. Now, I'll also represent that on like coordinate axis actually, just so that we can visualize it properly. Yeah. So what we observe from here is that the function A, that is our matrix, it takes this vector. Yeah, it takes this vector I cap and it basically transforms it sort of to this vector 1 I cap plus 3 j cap. And it takes this vector j cap and transforms it to this vector, right? Now like you might have like studied in previous standards, or like you would have heard that we can represent like any point on the coordinate axis with as a linear combination of I cap and j cap. So and like it is pretty easy to establish from stats also, because let us take any point this, we draw perpendicular on x-axis, we draw perpendicular on y-axis, we can see that this will have a particular x coordinate, right, and a particular y coordinate. We can write this x coordinate as a multiple of I cap, and we can write this y coordinate as a multiple of j cap. So basically we can write this x comma y as a1 I cap plus a2 j cap, right? Or b1 j cap. Like it really doesn't matter. But what I mean to say is like we take any two random a1 b1 and find a linear combination of I cap and j cap, and it will correspond to a point on the coordinate plane. I hope I'm clear with this.
Okay. So in the previous, I think in GeoGebra, what we did last time was we took two vectors, 2, 3, and 3, 4, which is nothing but the matrix 2, 3, 3, 4, right?
Yeah, yeah,
The 2, 3, 3, 4, and we were able to see that we were able to represent, in a way, we were able to reach any other point using
yeah,
2, 3, and 3, 4. But
yeah,
now you're
exactly.
saying, since 2, 3, 3, 4 is hard to find out where that point is, it's easy to use this 1, 0, and 0, 1, right? Is that what you're trying to say?
Yeah, yeah, exactly. Now I can establish that because I can reach anywhere in the input coordinate, like in the original red coordinate plane that I described, because
Yeah.
any point in the red plane I can write as a times I cap plus b times j cap. A and b can be anything basically. That covers the entire plane.
When you say A times I cap, it's nothing but saying scaling
Yeah,
I cap. Yeah, okay. And
yeah,
how much ever A is. Okay.
yeah.
So
So
scaling it by 3 means I'm going 3 units in the X direction.
yeah, right. So
Okay.
because I can go to any point on this on this red plane, I I am like translating it that every vector will have a transformed vector in the blue coordinate. Right now, how this blue vector basically, like what is the locus of this blue vector depends on the matrix that we are multiplying, but we'll see that later on.
Yeah.
Yeah,
One thing which is okay. So I thought you would highlight this point, but one point that I see from what you have written out till now, right? Can you go up a little bit, showing both the yeah, when you're multiplying the matrix A with 1, 0 and 0, 1, which is nothing but 1, 0 is I cap,
I can.
because that's like moving 1 unit in the X direction,
Yeah, yeah,
right? And where does the matrix take 1, 0, which is the 1 unit in the X direction, and where does the matrix take 0, 1, which is 1 unit in the Y direction?
yeah, exactly.
The best part about this I see is that it's very uh, good, like it's a very nice thing to see that it
Yeah,
takes X to the first, like the first column of the matrix is equal to where it takes X, right?
yeah, yeah, yeah.
Okay.
Yeah,
So
yeah. So yeah, so in the last lecture, one of my friends like described what a column picture is. So
yeah,
this is like exactly that. This is like another representation of this multiplication a times x, where a, let's say a has n columns basically, and x has n coordinates. We can represent this multiplication as uh, basically x y z, x times the first column plus y times the second column.
yeah, this is the column view.
Yeah, so yeah, so we can call this as the column picture.
Yeah, but the best part is if you make X, Y, Z as the unit vector, which is 1, 0, right? It
Yeah,
actually is
so
equal to the matrix's first column, right?
yeah, so
That's the
we are
best part I
basically
see
cherry
about
picking each column when we take
it.
the
Exactly.
unit vectors for each dimension.
So I can think about a matrix as, okay, the first column of a matrix tells me, let's say we are only working with a 2 cross 2 matrix. The first column of a 2 cross 2 matrix tells me where it takes 1 comma 0, which is
Yeah,
nothing
right.
but I cap. And the
Yeah,
second column of a 2 by 2 matrix tells me where 0
where it
comma 1
takes,
goes.
yeah, where it
Yeah,
takes 0 comma 1 in the blue plane.
exactly. Okay.
And this also we can observe that this is taking I cap to 1 I cap and 3 j cap in the output plane, blue plane, and it
Yeah.
is taking j cap to 2 I cap and 4 j cap in the output plane.
Yeah. Can we show this in GeoGebra? I think it should be
Yeah,
quite
sure.
straightforward.
I'll
Yeah.
switch right.
Sure. Unless you had something else to conclude by this. Yeah.
No, it
You
like
wanted to make another point? Any other points?
no. I just meant to say that because we can express this I cap and j. We can express any vector in this red plane as a linear
Yeah.
combination of I cap and j cap. We can also represent the transform vector. Like suppose we have a vector. Let's say we have this 2i cap and 4j cap. Um, no, we'll take some other vector. 2i cap plus 3j cap. We are writing this as a sum of 2 times I cap plus 3 times j cap, right? So what we'll say now, we know that in this blue plane, our I cap is going to 3 comma 1 j. Sorry, 1 comma 3, and our I cap in this blue plane corresponds to 1 comma 3. That means our 2 I cap will correspond to double of that, exactly double of that. That is 2 comma 6.
Yeah, but I
And
don't think this is very easy to see. Yeah,
yeah,
it's
yeah,
not easy to
yeah.
put this point through.
We
Maybe if
will
you go
actually,
step by step, yeah, I think we
yeah,
can
we'll
just show
actually
them.
illustrate that
Yeah,
on GeoGebra. That will be
understood.
interesting.
Let's show them how we are able to first express any point as a combination of I and j. I don't
Yeah,
think we've even got the term of linear combination in our discussions until now. I mean, at least
yeah,
through the questions that we've gone through. So let's just show them that what is the how can we use I and j, and similarly to how we span the entire. I mean, let me not use the word span also. We try to
yeah,
reach any point on the 2D space using 2 3 3 4. We can also do it with 1001, and it's much
1 0.
simpler that way. Yeah,
Yeah, right. So I'll switch to GeoGebra.
sure. Yeah.
Okay.
Can anyone else who's been active or who wants to just give a try, just give a brief understanding of what they understood by this by um, what I mean what was explained right now. Can they give their own explanation about it? I think if someone else also gives their point of view, we also will understand how much they've understood.
Yeah, actually, let's do it
Anyone wants
like
to give
that.
a go?
We can have an open discussion about it. I think that is
Exactly.
the best way.
That'll be better. Yeah.
Yeah.
Anyone? Anyone wants to give a go on what they understood until now? Or if they have not understood anything, just tell us. Um, we were just discussing nothing, and you couldn't get anything in your mind. That's also okay with us. We can take it slowly. It's only us students, and we're trying to help each other out.
Okay, there are students who still have doubts. You can see the questions in the chat box. So Ajit says that what is the relation between XY and AB in the last diagram?
So, do you want to show the diagram again? Did we have an XY? We had an XY. XY is the input. And
There's
you
a
want to
link
say
in the
AB
chat.
is the output, is it? Ajit, can you, if you're available on mic, can you just explain your question? What do you mean by X, Y, and AB? Because we only use numbers, right? I'm not able to understand what you understand as X, Y, and AB. No problem. If you have a problem with that, that's okay. So by XY, do you mean the input? You can just type yes or no. By XY, do you mean the input? Can't see his reply yet.
No.
It's okay.
Yeah, I'm sorry, I missed your question.
No, I think a student has a question on
Yeah,
what is the relation between XY and AB in the last diagram?
in the last diagram. Yeah,
Okay,
I
okay.
like.
Maybe we can explain the last concept once again because he can't use his mic and I don't think he can explain the problem in the chat box either. Maybe we can go
Yeah,
through that again.
just a minute. Start screen share. Yeah, so is my iPad screen visible?
Yeah.
Yeah.
Yeah, so do I start from expressing a vector as a linear combination of I cap and J cap, right?
Yeah, I think can you just show the two diagrams? What all diagrams do we have until now?
Yeah,
So we have a diagram that takes the input 1, 0. Okay. These are these the only diagrams we have?
Yeah.
Any other diagrams before this? Yeah. Okay, there's
yeah,
one
only
other.
this one. Yeah. So I think by last two diagrams, you mean these two diagrams, right?
Yeah, even I'm guessing that would be
Before
for
that,
this.
before that.
Before that, okay.
Hmm.
So this one.
Okay, Ajit, did you understand the first diagram in this page?
Laptop.
Yeah, so he happens to have understood that you can represent AB using INJ. Okay.
Right.
Yeah,
I mean, AB is nothing but going A in X direction and B in
I B
Y
and Y.
direction. Okay. So looks like he understood that. The next diagram, is that where you have a question? The one that is inside a blue box?
Yeah. Okay, so I'll like start with this again.
Yeah, yeah.
So that's also clear.
Okay, okay. So this one.
Yeah, I think you can just explain these 2 points again. I think, well, okay, let's think about, uh, yeah, let's just think about what a matrix does and just explain what happens when you input 1, 0, and 0, 1 again.
Yeah, right.
And once we do that, we can just jump to 0, 0.
Sure. So we'll take like another matrix for an example. Let's say B is equal to 1 0 0 2. This might be easier to understand a little bit. We'll have our input plane here red, plane as red, and our output plane as blue. Now, like we'll consider the unit vector in x direction I cap in the red plane. That will be 1 comma 0, right? So now I'll see what this matrix B is doing to 1 comma 0. Now, like before also we observed that we can express this as a multiplication of this quantity with this vector, this column basically, and this quantity with this column, right? We can verify that by
Yeah,
multiplication.
you can write it down. You can
We
write
can
it down.
write it as
Just to make it equal. You
we
can
can
break it
write
down. Just put 1 0 with 1.
yeah, we can 1 0 plus 0 times 0 comma 2. This eventually comes out to be 1 0. That means this function 1002 is taking an input is equal to 10 and giving us output is equal to 10 itself. That means our I cap in red coordinate is staying I cap in blue coordinates as well. So that will be this. This vector corresponds to this vector. Similarly, we'll consider this for j cap as well. That is 0 comma 1. Is equal to 0 times first column and 1 times second column. Now, like this term will become 0. So I can
0,2.
write it as 0 comma 2. Right. Now, like we can observe that this matrix B takes input as 0 comma 1, that is j cap basically, and gives us output 0 comma 2. Now this 0 comma 2 means means we are moving 2 units in the y direction, right? So this corresponds to 2 j cap in the blue coordinate system, like as in this vector in red coordinates corresponds to this vector in blue coordinates. I hope it is clear how the function how this matrix is a function and how it is modifying the input and giving us the output here.
Basically, the matrix is representing the first column where it is taking 0, 1 0, and the second column where it is taking 0 1. Yeah.
Yeah.
So I have a
Now,
query about it.
Okay, we can move to GeoGebra, I guess.
Yeah.
yeah,
Someone
yeah.
has a query.
Let's
Go
let's
ahead.
go to GeoGebra. It will be clearer. It will be clearer there.
yeah. So the query is like whether the column, right? So the first element of the column, which belongs to x-axis, the first element will scale scale that vector, and the second element will rotate that vector. Is it correct? Or
Uh,
only with respect to first column, like only with respect to x?
I think rotate is not the right word. We can call it shear, because hold
Okay.
on, I'll do that on iPad as well before we move on to
Yeah,
GeoGebra.
sure. Yeah.
So we can basically understand that if we take 1 0 and 0 1 in the matrix, that basically takes I cap in red coordinate system and corresponds it to I cap itself in blue coordinates also. And same for j cap also in red coordinates, it corresponds to j cap in blue coordinates. So basically, there is no difference between red and blue coordinates, right? That's why, like, when we multiply 1001 with any vector xy, it remains xy. Am I clear about this? Hello.
Yeah,
Yeah.
pretty clear.
Yeah. Yes.
Sure. So Now that like you have mentioned about that, I'll discuss a little bit about what I mean by shear, right? So I'll take a matrix A is equal to 1, 2, 0, 1, right? I'll analyze what this matrix is doing to I cap and what this matrix is doing to J cap.
As per understanding, the I cap remains same, but J cap has
Yeah.
to share.
Yeah, so I'll just straight away draw this. 1 times 1, 0, that's 0 times whatever. So I cap remains I cap, and 1, 0, 2, 1 times 0, 1. This takes 0 times 1, 0 plus 1 times 2, 1. So that means J cap is, this J cap is going to 2 I cap plus J cap, right? So this vector, which was initially vertical, this slides along this line. Uh, can you visualize that? I'll show you one of, like, I'll show you a simulation as well. Let me just get that up.
Yeah, sure. So why I posted this question? Because actually this question was with me for several years. Why the matrix elements, what each element will do. So now only I got to know about the written. That's why I question.
Yeah. So I'm actually sharing a link on chat. You can open that.
Thank you very much for coming out this evening. Thank you. Too kind.
We can hear the music there.
That woke me up.
Are you on mute by any chance?
Yeah, I'm really sorry for that.
That's okay.
Yeah. It's actually not my PC, so I'm not used to it. I hope my screen is also visible here.
Yes. Yeah.
Yeah. So this is just a random image that we have here. Let's not get into why there is an image and what are these arrows. We'll just see that these this matrix that is written here is, we are basically multiplying that matrix to any x comma y in this figure, and it is doing something and it is changing the figure. So we'll just observe what is happening here. Now if I'll change this first entry in this column to 2, and the image gets fat. I'll change it back to 1, and I'll change the other entry to 2. The image gets taller. I'll change this 0 entry to something, let's say 1. The image shears, basically it shears like this. I change this other entry to 1, it shears in y direction. So I'll suggest you play around with this for a minute and we'll get back after that. Hello.
Can you try -1, 0, 0, and 1?
Sorry.
Can you try -1, 0 in the first column and 0 and 1 in the second column?
Yeah. Right.
What about the chat? I'm just asking the students here. What values will rotate this image? Can you make it back to 1001?
Yeah.
Yeah. What about a rotation by 90 degrees? Say clockwise rotation of 90 degrees.
Maria, your voice is breaking, I guess.
Is it audible now?
Yeah.
And it's
Yeah,
fine.
okay. Yeah, like when you want to rotate the matrix by say theta degree, like there's a special type of matrix called rotation matrix, right? So when it's 2 into 2, I guess it's and I have a doubt about the like about the diagonal elements. I think it's cos theta, sin theta.
If you play around with
Such a
values, so think about it, right? What do you want to do? You want to rotate it 90 degrees. So what is at 1, 0, which is the x-axis, which is on the x-axis, has to now go to the y-axis on the negative side. So what does that mean? 1, 0 should
when
go
you
to,
visually think about it, okay, yeah.
yeah. Don't think about it about the nitty-gritties of how do you flip it. Just think, try different values. Like I think Chetan has already answered it, right?
Yeah, it's that. Yeah, it's there in the chat.
Yeah.
Yeah. Okay, so yeah, when you think about it in that way,
Yeah, that's
yeah.
what you should think about. So when you think about a matrix, try to think about, okay, if you look at the 2 cross 2 matrix, the first column is just telling me where 1, 0 is going, right? So what do I have to do? I have to make sure 1, 0 goes to -1, 0. Sorry, 0 and -1, and 0, 1 should go to 1, 0, right? If you think about it, right? 90 degrees.
I get, yeah, like it's also easier with the picture. Yeah.
Yeah, exactly. Hello, Ankit. Not so we were trying to discuss
Yeah.
how we can represent any point. So how do you represent a point? Let me just give you a quick overview as well. How do you represent a point? You represent a point on the coordinate plane as x comma y, right? And x in itself, right? The intrinsic meaning of x means nothing but how many units are you going in x direction, right? So if I say 2 comma 3, I'm just saying go 2 units in the x direction and 3 units in the y direction, right? So what is that single unit you can think of, right? So that brings us to I cap and j cap. If you've already learned what I cap and j cap is, this is what it is, right? It's just telling you what is a movement in the direction of x in 1 unit. What is 1 unit of movement in the x direction, right? I cap is nothing but 1 unit movement in x direction. J cap is nothing but 1 unit of movement in the y direction. And you can represent any point on the plane using a combination of this, right? And this can also help you to see how, I mean, now we look at a matrix and we try to see where does it take 1 comma 0, right? Where does it take the unit vector of x, right? And where did it take the unit vector of y? And we can look at it in this picture, right? If we try to change the values of the matrix, you can open up the link from the chat if you have not already. And you can try different values for the matrix, right? Keeping in mind that whatever the first column of the matrix is telling you, it's telling you where 1 comma 0 will go to. And the second column is telling you where 0 comma 1 will go to. So this is just a summary. And we're just trying to find ways of rotating the image by 90 degrees, maybe flipping the image. What about squishing the image? Anyone? Can you give an example?
You can try around at your end and then just let us know what
Yeah.
inputs you in the matrix. We'll discuss on that.
What do you mean when you say squishing?
Yeah. So what I mean by squish is I want the entire, okay, all the points on the image, instead of being mapped to, okay, let me think about this. How do I frame this? Okay, if I think about it in 1, 0 and 0, 1, I'm saying the matrix is telling me where 1, 0 and 0, 1 goes. I want both the first column and second column to lie on the same line. That's all I'm trying to say, right? Do you
So
understand
that
that?
is basically whenever determinant is 0, it's coming like that, but I don't like this.
Yeah, I don't know. Okay, let's say I don't know what a determinant is. I don't know. I've never heard of a determinant, but I understand that the matrix is telling me where 1, 0 is going and 0, 1 is going, right? I am saying, what if I make both 1, 0 go to a point, right? And the second point, which is the second 0, 1, I want that also to go to a point lying on the same line of 1, 0, of where 1, 0 went, right? I want the 2 points to be collinear.
So we can try that on
So
this as well.
yeah, 1, 2, 1, 2, we can try.
So let's say in the first column, let's say I cap in the original matrix goes to 1 comma 2, and the second column, that is J cap, goes to 2 comma 4, which is basically twice the first column, right? So it is in the same line as the first column.
You can start with 1, 2, 1, 2. Like he said 1, 2, 1, 2, right? Try to keep
Yeah,
1,
sure.
2, 1, 2. Right? This is more easier to understand. Exactly. So
Yeah.
now what is happening? The image is vanished, right? The image is actually squished. Why do you think that image is squished?
By squished, you mean that it's restricted to that direction alone? Is that what you mean?
Yeah.
Yeah.
One dimension has been lost completely. It's all in that one.
We can
That
also see that by varying this by a little bit. So for example, here we had 1, right? So we'll make 1 as 0.09, 0.9999 something.
Yeah.
I'll take that closer to the 1 and we can see how this image is going to squish around.
Can
And
you start from 0.5 maybe? Start from
yeah,
0.5.
let's start from 0.5.
Yeah, we see that it's been being squished in one direction now, a little bit. Let's go to 0.8 maybe.
0.8.
Yeah,
Yeah,
okay.
right.
Yeah.
Squished it a little bit more this time.
Yeah.
Now,
Go ahead.
yeah. I'll just continue going to 0.9.
Okay. I get the idea. Like you're applying force on both sides so that it kind of gets restricted to both. Yeah, I think I got the idea.
Yeah.
Yeah, sort of.
Is it the same as 1100?
1100. Yeah, 1100 also gives us the same, like, this also gives the same result, because basically the first column is taking I cap to I cap itself, and the second column is taking J cap to I cap again. So both of them lie in the same line, right? That means the image shrinks to one line itself,
Right.
and we can see it anymore.
Actually, could you come again with this particular concept, like why why it is reducing to one dimension, how it is happening?
Yeah, sure. I'll let we discussed a little while ago, that the first column represents what coordinate we are taking the I cap unit vector to, right? And the second column represents what coordinate we are shifting J cap to in our new coordinates, in our transformed coordinates, you can say. So
Okay.
in this particular matrix, we can see that this first column is taking I cap to 1 0, which is I cap itself. That means I cap is not changing, it is I cap only. This second column, that takes J cap and shifts it to I cap. So what was J cap in our original coordinate system, that also corresponds to I
0,
cap.
1.
So both of them now lie in the same line as well.
Oh, so okay.
Yeah.
So that means like 1, 2, 2, 4, what it resembles, it means the I cap and J cap lies in a collinear, like the same line.
Yeah. So
Yeah, there's a subtle
I cap.
difference here actually, right? Previously they lied on the same line, right? But now even 1 comma 0 is being mapped to 1 comma 0. 0 comma 1 is also being mapped to 1 comma 0. Actually, every point on the plane is being mapped to 1 comma 0. So now we are no longer creating a line. We are only creating a point, which is the transform picture is actually only a point. Is that true? Is that true? I'm asking. I'm posing this question.
Yeah.
Since 1 comma 0 is going to 1 comma 0 and 0 comma 1 is also going to 1 comma 0.
Yeah.
Every
So
point on the plane is going to 1 comma 0. The third
no, not.
statement which I'm making is not
Yeah,
very
it is.
clear. Yes.
Yeah, it is not correct. So
Yeah.
every point on our original coordinate systems, we can write that as x I cap and y j cap, right? That basically corresponds to the point x comma y in the original plane. Now we
Exactly.
are saying that this matrix takes I cap in original coordinate system to I cap. That means I cap remains unchanged, and j cap also
Yeah.
to I cap,
Can
right?
someone? Yeah. I just want someone else to also. I want them to try to defend what they think, right? I want anyone else to also give their point of view. The third, I made three statements. The first statement was 1, 0 is going to 1, 0. 0, 1 is also going to 1, 0. Does that mean every point on the plane, no matter what point I take, is it going to 1, 0? Anyone can answer. I just want someone, maybe even new, more than who I mean, there have been a few students who have been active, and I just want anyone to give their point of view on this.
I think the direction would be 1, 0. Like every point won't go to 1, 0, but the direction would be in that direction only, right?
Yeah,
Yeah.
because we can scale it
XY will
up and down.
scale it, right?
Yeah.
So
Yeah.
whatever our
Exactly.
XY column will be.
Yeah,
uh,
taking an
it will-
example makes it all easier, right? If you
Right.
take a point 2, 0, right? 2, 0 is not going to 1, 0. It's actually going to
Like with same direction with twice as the scale would be the
2,
2,
0,
0
right?
only. Yeah.
2,
Yeah.
0.
exactly.
2, 0.
It also goes to 2, 0. What about 2, 3? Where is 2, 3 going?
2, 0.
Yeah.
Hmm?
So the value of y. Wait 1 second.
No,
Is that true?
I think
I don't think so. It's 2
yeah,
plus
2,
3, right?
3,
It becomes 5, 0.
5, 0. Yeah.
Do you understand? Because it's 2 times the first vector plus 3 times the second vector, which is
5, 0.
yes, exactly 5, 0. Do you understand that, Janendra?
Yeah. Some
Yeah,
okay.
yeah.
In the same
yeah.
direction, but yeah. Sheer.
What
Okay.
if, yeah. Now you've seen that some matrices take it to a line, some matrices take it to a different point, like make it, shear the image or maybe scale the image, do some rotations to the image. Can you give me a matrix that takes every point to a single point?
0, 0, 0, 0.
Exactly.
Yeah.
0, 0, 0, 0 is the only possible answer.
Special
Right.
case.
Yeah. That's it. Again, if anyone didn't understand that, they can still ask us, how is that possible? Why is 0, 0? I mean, when I took 1, 1, 0, 1, 0, it was spanning. I mean, I was able to go in a line. But if I put 0, 0, 0, 0, I can only go to a point. Right? Whatever function I take, whatever input I take, is going to take me to 0, 0.
But I think that's both the matrices of 0, 0, 0, 0 and 1, 0, 1, 0 have a similarity. That is, we cannot
Yeah.
do any operation. We cannot undo the operations in the when we are operating using these matrices. No.
Yeah.
Yeah. Can you like give a reason why you can't undo that?
Like
Maybe
if you multiply a matrix by a matrix of 0, 0, 0, 0,
yeah.
there is no valid operation if we can recover the original matrix. Similarly,
In first
it's
principles. No. In
Yeah.
first principles, can
Maybe
you
maybe
try to give a reason?
you can try to think geometrically about that.
Yeah. We
yeah,
talked about.
we are not taking none of the existing this thing, or we are just altogether dropping a column or a row. In that case, if a multiplication results in a dropping of a complete row or a complete column, in that case also we lost some information which is not recoverable.
I'll ask you a
Yeah.
question.
Yeah.
Where is 2, 0 mapped to? Where is 0, 2 mapped to?
2, 0 and 0, 2. It's about one is x-axis, one is y-axis.
Yeah. Where is it mapped to? In the output of 1, 0, 1, 0. If I input 2, 2, 0 to the matrix 1, 0, 1, 0, which is given on the screen, where does it go to?
2,0 will actually I just joined a few minutes earlier.
2,0.
Oh, that's fine.
Uh,
Try to
0,
multiply
2
the.
will
but
No, no, 2,0 itself, right?
but
no,
two
0, 2 will also go to 2, 0, right?
Exactly.
no no
So two inputs are giving the same output. So now can you think about why you're not able to invert in this sense? There's an output 2,0, but there are multiple inputs that it could have come from.
that
What is
is
this function of a
Like,
function? What do we call it?
it is not a
1 to 1.
one-to-one function.
no, it's not
Exactly.
on 1 or on 2.
It is not one-to-one because for an output we don't have a unique input also.
Yeah, it's not 1 correct. Yeah.
Yeah,
It's not on to either. So it's not invertible.
exactly. Any point outside that line is also not even reached by the. So any
Yeah,
point which is
so
not on the line does not have a input.
our
Yeah,
output is restricted to the x-axis, right?
Right. Right.
exactly. Janendra, what have you shared? What is it about?
Oh, just yesterday's link to visualize the uh, mappings.
Okay, yeah. The side by side mapping, right?
Right, right.
Yeah.
Okay. Makes sense. Okay, so what we've seen till now, um, can someone give me a overview? Maybe Maria, do you want to just give an overview of what we've discussed until now?
Okay. So first thing I guess we learned when we started with linear algebra was that you can associate a matrix to a function. So then
Yeah,
we tried, yeah, then we saw how we can invert a 2 into 2 matrix easily. That is, you, okay, I don't remember the exact way, but there was a shortcut also that he mentioned.
yeah.
If
A few
someone, yeah, knows
steps.
it,
Yeah, a simple steps. Few simple steps.
yeah, like if someone who
Replace the
knows it can
position of A and B and invert the signs for B and C
Exactly.
and
Yeah.
divide it by
So
the determinant.
yeah,
the matrix is A, B, C, D column row wise.
yeah.
A, B, C, D
Exactly.
wise.
Okay, yeah. So they mentioned that. Okay, then what else? Yeah. Then another thing I like from all these classes that I actually really liked was this. I guess that was during one of the late night discussions. We had this concept like when you have two independent vectors. Someone actually showed it on GeoGebra how it actually spans the entire R2. Like he mentioned that yesterday too, I think. Like when you can actually reach any
Yeah,
point in R2 using two independent vectors and the linear combinations. So
yeah.
that
We don't
idea
know what
geometrically,
independent is till now, but it's
okay, yeah,
okay.
two
Yeah,
independent. Independent in the sense that like if we take the two columns, they're not multiples of each other. They're you can associate them
yeah.
like
They
you
don't
don't
lie
need,
on the same line.
Yeah.
yeah. You can represent you need two different representations for it. Like you can't use one vector to represent the other one too. Yeah.
Yeah, that is also
And
true. Yeah.
so those are things that majorly stuck out for me. And then
Column
now,
pictures.
yeah, column picture. Yeah, column picture. Okay, so column picture of matrix multiplication, I think, uh, yeah, that was also pretty cool. Like you can take if you are multiplying 1, 2, 3, 4, and 1, 2 is in one row, 3, 4 is in another row into x, y. You can write it as 1, 3 into x plus 2, 4 into y. So that's a column
Mentally, it's hard.
picture.
Why
Scale the
don't you start
vectors.
sharing your screen? I think you were due sharing your screen yesterday. So why not we start now? Okay. So officially class is over. We just wanted to summarize everything. So if you want to stay until the summary is done, you can do that. And a few students here like Chetan, Janendra, Nishan, Maria, Ankit. A lot of us have been discussing for a long time, Rishabh and Anamika. So if you want to stay and you want to continue discussing, I think we really have some we tried delving deep into the topic. We try to ask a lot of questions and try to figure out things on our own. Yesterday, even Sir was available for a while, and he also tried to guide the session in a particular way. So if you are up, you can also stay for. I'm not going to guarantee how long. It's always
Yeah.
it's a variable that keeps exponentially increasing. So we can't say for sure. So if you want to stay along and you want to, and if you can be part of the conversation, discussions, it'll be really nice. But if